So let's consider now where we have two events, okay, or I suppose two trials with two events as the outcomes, and looking at and working with the sample spaces that are generated, okay. So let's throw two dice and find the probability of the total score is 7 is less than or equal to 4, greater than or equal to 11. Total score is a multiple of 5 or of getting a double, okay. Well, to do this, we need to first do out the sample space, okay? And what I've done here is I've diced 1 along here and diced 2 along there. And I've divided the grid into, in the top corner of each box, I've put the possible outcomes. So a 1 and a 1 is 1, 1, a 2 and a 1 is 2, 1, 3 and a 1 is 3, 1, and so on. And to save time and space then, in the other half I've added the 3 and the 1 to give me 4, or the 2 and the 1 to give me 3, because this is, you know, what we're looking at, totals. Okay, so I've just put it all in the one box. So that's all we're saying here. I have the outcomes in there and the total of the two outcomes in here. Okay, so we've set out the sample space and we've also recorded the totals as well in one go. Okay, now we'll work with the probabilities. So the probability that the total score is 7 is any of the boxes in the sample space where the total is 7, and there's 6 of those, so it's a 1 and 6. Where they're less than or equal to 4, we'll count up how many there, and there's 6 in the grid here. Less than or equal to 4 totals is 6 and 36 is 1 and 6 again. The probability of the two dice yielding a result that's greater or equal to 11, there's 3 possible outcomes there over the sample space number is 1 and 12, and the possibility that the score is a multiple of 5, there's 7 chance there, so 7 and 36, and the possibility of getting a double, well, there's 6, there's the 1, 1, and the 2, 2, and 3, 3, and the 4, 4, and 6, 6, 5, 5, 6, 6. 6 and 36 is 1 and 6. So that's, you know, we've worked with the sample space, we've drawn the sample space, but we've also worked with it in that we've totaled the actual outcomes. Okay. Now here's another question here from page 187 in your book. 3 fair coins are tossed. Make a sample space, and find the probability of 3 heads, 2 heads and 1 tail, no heads, and at least 1 head. Okay. So we know that if we've 3 coins, 2 possible outcomes, that's 2 by 2 by 2, is 8 possible outcomes in the sample space, and they're just listed there. Okay, and so working with this, then the probability of 3 heads is 1 in 8, of 2 heads and a tail is, sorry, the probability of 2 heads and a tail is 2 in 8 is 1 in 4. The probability of no heads is 1 in 8 there it is, and the probability of at least 1 head is 7 in 8. Another example, Chloe is playing a word game and chooses a vowel and a consonant at random from the words or letters, A, E, I, R, L, D. Okay, so if we draw a sample space, we can draw the vowels along here and the consonants, the R, L, D, here. It's on page 188. Okay, what's the probability? I'm going to do the sample space. What's the probability of Chloe picking A and R? Well, it's with this 1 in 9. And I and L is 1 in 9. And the probability of picking an I but no L is 1, 2 in 9. Now let's look at estimating probabilities from experiments, because we have to bear in mind that not all things are equally likely to happen. So if we were looking to find the probability of the next car coming around the corner to be a certain colour, you know, any car of any colour could come around the corner. So often we experiment or survey some trials to find what's known as an experimental probability or a relative frequency to estimate the true probability of an event occurring. So we use this formula that the experimental probability or the relative frequency is equal to the number of successful trials divided by the total number of trials. And statisticians have found that as the number of trials increases, in other words, the more trials we do, the experimental frequency, or the relative frequency, this value here, will get closer and closer to the true probability of that event happening. Okay, and also we can say that the expected frequency, which is another term, which is like another way of saying the number of successful trials, is equal to the probability times the number of trials. I guess the best thing to do is to look at a couple of examples. So some guy stood on a corner and he counted how many white cars came, how many red, black, blue, green, and other colours. Okay, so he noted the frequency of them occurring. And so the first question is how many cars were surveyed? Well, you add all of these up and you get 100. And then we're asking what's the relative frequency of a blue car? Well, the relative frequency is from the formula here is the number of successful trials, number of blue cars, divided by the total number of trials. So that gives us 16 blue cars from the table. Over 100 is 4 over 25. And what would be the probability that the next car coming around the corner is green? Well, we simply need to find the probability of a green car from the table, and that is 10 divided by 100, 1 in 10. And how can we make the probability of the green more accurate? Well, if we were to just increase the number of trials, then the true probability would get closer and closer and closer. Okay? And the final question is, if 200 cars were surveyed, how many would you expect to be black? Okay, so for this one we'll actually apply the expected frequency formula here. So the expected frequency is the probability, okay, of black cars, which is 14 over 100, multiplied by the number of trials, which is 200, and that gives us 28 cars. We'd expect 28 cars if we surveyed 200 to come by. Final example now. David and Rory are keen golfers. Out of the last 20 rounds, Rory won 14. Based on these results, estimate the probability that David will win the next round. Well, David has won 6 out of 20, so the probability of a David win is 6 over 20 is 3 in 10.3. Given that David wins the next 5 rounds, estimate the probability that Rory wins the next one after that. Well, after 25 rounds, the probability of the next win being a Rory win is 14 out of 25. And the probability that David winning, or when we get David win, is the 6 he originally had plus the 5 over 25 is 11 in 25. So the probability that Rory will win is 0.56.